Welcome to the third and final part of this lesson about dilations, and in this part of the lesson what I'm going to be showing you is a quick and efficient way of answering these type of questions as opposed to the long procedural way that I've shown you in previous parts. So let's get into it. So here's a really useful table that I want you to be referring to. So it tells us that when we have a dilation from the x-axis, a really quick way to answer it is simply go the factor that it's being dilated by times the function itself. And also, if we have a dilation from the y-axis, a really good way to quickly find it is simply sub into the x position here, x over whatever the factor is. So let me now show you what this looks like in practice. So it says, find the equation of the image of y equals the square root of x dilated from the x-axis by a factor of 5. So as you can see, we're dilating from the x-axis, and here this tells us simply take the factor and multiply it by the function. So that means my answer is going to be y equals 5 the square root of x. Pretty easy. Let's come over here. Find the equation of the image of y equals the square root of x dilated from the y-axis by a factor of 5. So here we're dealing with this one right here. So what we're going to do is we're going to sub into the x position, x over what the factor is. So I'm going to get y equals the square root, and then into the x position, I'm going to sub in x over 5. And that's my answer. Let's now do some more examples. Here we have find the equation of the image of y equals 1 over x squared dilated from the x-axis by a factor of 1/4. So this is an instance when we're dilating from the x-axis. So we're going to multiply this by 1/4. So it's going to be y equals 1/4 multiplied by 1 on x squared. So my answer is going to be 1 over 4x squared. Let's come over here. This time we have find the equation of the image of y equals 1 over x squared dilated from the y-axis by a factor of 1/4. So in this instance, what we're going to do, in our x position here, we're going to substitute in x over what our factor is. So our factor is 1/4. And remember, this whole thing is being squared. Now this kind of looks messy, but remember when you got x over a fraction, or anything over a fraction, what it'll end up being is 1 over 4x squared, and that is going to be equal to 1 over 16x squared. That right there is going to be my answer. Let me just highlight my answer there so we're all on the same page. This is my answer here. This is my answer there. If you're just wondering, let me just do this off to the side. So you might not need this, but I just want to make sure that I'm covering everyone here. If I've got x over 1/4, so that's what we had here. The way I like to think about it is x divided by 1/4. That's the same thing. And then you can say, hey, state change flip, x times 4/1. And remember, everything is over 1, so it's 4x. That's what I'm doing there. That's how I got it. Just to make sure we're all on the same page. Okay, let's now go through these ones. It says, find the equation of the image of y equals 1 on x plus x dilated from the x-axis by a factor of 3. Well, because I'm dilating from the x-axis, that means I'm simply going to take the factor and multiply it by the entire thing that I'm given. So that means I'm going to end up with 3 on x plus 3x. Okay, then we have find the equation of the image of y equals 1 on x plus x dilated from the y-axis by a factor of x. So in this instance, every time I see an x, I put into that x over what the factor is. So here, this is going to be x over 3 into that x position. A better way of writing this is going to be 3 over x plus x over 3. That's going to be my answer there. Let's highlight these. That is my answer here. This is my answer here. If I can just think for a moment, I think some people might be a bit stuck on how I went from 1 over x on 3 to 3 on x. So what I did there is it's 1 divided by x on 3, right? So that's the same as 1 times 3 on x. Remember, everything is over 1, so it's just 3 on x. State change flip is a beautiful thing. And, you know, if you ever get stuck on things like that, just remember, state change flip. Okay, now there's one instance where doing this shortcut isn't going to work. So as you can see here, everything is y equals, y equals, y equals, y equals. And that's why we can think about it in these terms. But let's say you're given something like this. So this is a circle. And as you can see, it's not y equals, it's x squared plus y squared equals 9. When you're facing something like this, you have to revert back to do it in that long procedural way. So let's do it. And this is a good one too, because we have two dilations occurring at once here. Okay, so we have x squared plus y squared equals 9 dilated from the y-axis by a factor of 1/2, and then also from the x-axis by a factor of 1/3. So in this instance, what I would do is the long way. So we would go, all right, I have x, y. Then I have this. Then I rewrite it. I know that x dash is going to be what? Well, it's a dilation of from the y-axis by a factor of 1/2. So because it's dilated from the y-axis, that means it's going to be 1/2 x. And then here from the x-axis by a factor of 1/3. So it's going to be 1/3 y here. Then I create my equations. 1/2 equals x dash. 1/3 y equals y dash. I now solve it for x. It's going to be x is equal to 2x dash. Y is equal to 3y dash. Just in case you're confused as to how I did that, what I did here is I simply timesed it by 2, which cancelled those out, and I'm timesing that by 2. Here I times it by 3, times it by 3. That's going away. That's how I'm getting 3y there. Then what we do is once we have these fantastic equations is we remind ourselves of the graph we're dealing with, the original one, so this one right here. And now we substitute in these values. So it's going to be 2x dash squared plus 3y dash squared equals 9. My answer is going to be 4x squared plus 9y squared equals 9. And as you can see there, I dropped the dashes as well. We don't need them. Perfect. Now let's do the final question here. And hopefully by the end of this, you're feeling very confident with dilations. So yet again, as you can see, it's not y equals. And because it's not y equals, don't use the shortcut. Do the long way, just so you can be 100% sure of your answer. Now, what is my x dash going to be? Well, it says I'm dilating from the y-axis by a factor of 2. So that means it's going to be 2x. And then my y dash is going to be, I'm dilating from the x-axis by a factor of 1/4. So that's going to be that. Then I'm going to go 2x is equal to x dash. 1/4y is equal to y dash. Now we have to be careful here on how we do this. I'm going to go divide by 2, times by 4, times by 4 in order to solve for my x and y here. So that means the answer I'm going to get is x is equal to x dash on 2, y is equal to 4y dash. Then I remind myself what the original graph is, which I get from here. Into the x position, I put this, x, that. Into the y position, I put this, 4y, that, dash, squared plus 4. Now, because this is x equals, I'm just going to leave my answer as x equals as well. So I'm going to drop my dashes, and I'm going to end up with this. So just to clarify what I did there, I times this side by 2, and I times this side by 2. And remember, you're timesing this entire side by 2. So those 2's went away, and now it's 2 times what's inside here. I also went 4 squared is 16, y squared is y squared. And then finally, if you wanted to, you could expand out that 2, which means my answer is going to be 32y squared plus 8. And that would be our final answer. Perfect. So we've covered a lot in this lesson, but I really wanted to be thorough, and hopefully you're feeling really confident about dilations and also just about transformations in general and just this procedure right here, which can be a little daunting at first. All right, I will see you in the next lesson.